All right, let's talk about something that affects a massive number of people all over the world, but most of them don't even know it. We're diving into latent tuberculosis, a hidden threat that we're going to bring into the light today. So picture this. What if an infection could just set up camp inside your body and you feel totally fine? No cough, no fever, nothing. This sounds like something out of a movie, but it's the reality for millions of people living with a latent infection. It's a silent passenger. So what is latent tuberculosis, or LTBI exactly? Well, it's pretty simple. It means you've been infected with the TB bacteria, but your immune system has it on lockdown. It's walled off, contained. You don't have the active disease, you have zero symptoms, and this is the really important part, you're not contagious. You can't give it to anyone. Now you might be thinking, if it's not active, what's the big deal? Well, here's the catch. The risk is that it can wake up. For about 5 to 15% of people with latent TB, that sleeping bacteria can reactivate and turn into active, contagious tuberculosis. Think about that. For every 100 people with latent TB, up to 15 of them could get sick if it's not managed, and that risk is way higher for people with weaker immune systems. So, how in the world do you find an infection that's hiding? Well, the first tool we ever had for this has been around for over 100 years. It's a real classic in the world of medical tests. Yeah, you have to rewind all the way back to 1907. That's when the Tuberculin Skin Test, or TST, was discovered. For more than a century, this has been the standard, the go-to method for figuring out if someone's been exposed to TB. The most common version you'll see is called the Mantoux test, and it works in 3 clear steps. First, a really tiny amount of a substance called PPD gets injected right under the skin on your forearm. Then you play the waiting game for 2 to 3 days. Finally, a healthcare professional takes a look. And this is the part that really matters. They measure the firm, raised bump, the hardening, not just any red patch around it. So what do the results mean? It's all about the size of that bump. If it's 10 millimeters or bigger, that's a positive result. Less than 5 millimeters? Negative. But what about that weird in-between zone, from 6 to 9 millimeters? Well, that's considered doubtful, kind of a gray area, and it might mean more tests are needed. Now, this is where it gets really fascinating. A positive test means something totally different depending on how old you are. In an adult, it usually just means you've been exposed at some point in your life. It's like a footprint left behind. But in a child, a positive test is taken way more seriously. It's seen as a sign of an active infection happening right now. But, despite being the classic test for so long, the TST has some major drawbacks. It can give you a false positive, especially if you've had the BCG vaccine for TB before, and it can also give you a false negative, missing the infection entirely in people who just got it, have really advanced TB, or have a weakened immune system, like with HIV. So all those limitations really pave the way for something better, something more modern. We now have a high-tech alternative that tackles the old test's weaknesses head-on. And that alternative is called an Interferon Gamma Release Assay, or IGRA. Instead of a skin test, it's a blood test. The science behind it is actually pretty cool. It takes your blood and basically asks your immune system, hey, have you seen these specific TB germs before? If your cells remember the bacteria, they release a chemical called interferon gamma, and the test picks that up. And here is its single biggest advantage, the absolute game changer. The specific things the IGRA test looks for are not in the BCG vaccine. What does that mean? No more false positives because you got a vaccine as a kid. This makes it a much more accurate test for millions of people. Okay, so we have the classic test and the modern one. Let's put them side by side, a real head-to-head comparison, so we can see exactly how they stack up. Let's break this down. The TST is an in vivo test, meaning the reaction happens in your body, on your skin. The IGRA is in vitro. It happens in a test tube in a lab. Because of that, the IGRA has much higher specificity. And here's the knockout punch. The IGRA is not affected by the BCG vaccine, but the TST is. That's usually the deciding factor for doctors. All right, so you've had a test, and it comes back positive for latent TB. What now? Well, the conversation completely shifts. It's no longer about diagnosis, it's all about prevention. It's time for an action plan to make sure that infection stays latent. The entire goal of treatment here is to stop it in its tracks before it can even start. The fancy medical term is chemoprophylaxis, basically using medicine to prevent a disease. By treating the latent infection, you can seriously slash the risk of it ever waking up and becoming active, contagious TB. Now, this preventative therapy isn't for just anyone. It's specifically for people who are at a higher risk. This includes folks like adults and kids who are living with HIV, since their immune systems make them much more vulnerable to TB becoming active. This quote really says it all. The most common medication used, called isoniazid, does two amazing things at once. It stops the latent bacteria from waking up, and it can help protect you from getting a brand new infection. It's a seriously powerful tool in the global fight against TB. So after all that, the history, the tests, the treatments, what's the big takeaway? What's the one thing you should remember? It really all boils down to a simple, powerful idea. Here's the bottom line. Yes, latent TB is incredibly common, and yeah, it's completely silent. But it is not some scary, unknown mystery. Thanks to more than a century of science and incredible tools like the IGRA test, this is a condition we understand really well, and it's totally manageable. We know how to find it, and we know how to keep it in check. And all this progress leaves us with one final big question to chew on. As our diagnostic tools get even sharper and more accurate, should we be changing our whole strategy? Should we rethink who gets tested for latent TB in the first place, so we can find it and treat it before it even has a chance to cause trouble? Definitely some food for thought. Thanks for joining me.